Section 40 is entitled Iterated Integrals in Area in the Plane. Do some simple integrals. Suppose you were asked to solve this integral. The integral from 0 to x of 2x minus y dy. The y tells you the dy, or the y in the dy tells you that the variable for this integration is y. That is, we're integrating with respect to y. So x and z and q and r, they're all constants. So with respect to dy, or with respect to y, this is a constant. And the integral of a constant times dy is that constant times y. And just think of this as 7. If I asked you what the integral of 7 dy was, I'm fairly sure you would say 7y. Okay, minus the integral of y is y squared over 2. And we are to evaluate this from 0 to x. Remember, if that letter over here is y, then these are y limits. Y equals x, y equals 0. So I replace y with x. So I get 2 times x, which is 2x squared, minus x squared over 2. And it turns out when you plug in 0 for y, you'll get 0. So you take away 0, and as a result, that's the answer, except now I'm seeing that they're all y squares, and we can deal with that. Here I have 2 y squares, and I'm taking away a half. Well, 2 minus a half is 1.5. You really have to start catching on. That's 1.5. Just like when you look at 2 plus 2, and immediately you think 4, when you think 1.5 or see 1.5, 3 halves. So we have 3 halves times x squared. As always, let's try another one. Suppose you have the integral from e to the y to y of ln of x over x. So y ln of x over x dx. So basically the y, not being a function of x, it's a constant. You can bring it in front if that makes you happier. Now, actually, I just want to write it a little bit differently. I can divide the dx by x. 3 times 4 sevenths is the same as 3 sevenths times 4. After all, in either of those cases, you multiply the tops, and there's only one bottom, it stays that way. You multiply the tops, 12, divided by 7. Now, if I call that u, if I let u equal ln of x, well then du is 1 over x dx, also known as dx over x. So this is u, and that's du. Well, I know the integral of u du. It's u squared over 2. But this is how I write u. It's u squared over 2. Now remember, since that's x, those are x values. X goes from e to the y to y. So y over 2 is a constant. Let's actually factor it out. So then I get ln of y all squared minus ln of e to the y all squared. But remember, ln of e to the anything is just the anything. So I get y over 2 in front, ln of y quantity squared minus y squared. Because what's in here is just y. Ln of e to the y is just y. What's in these brackets is y. And it tells me to square it. And there's the answer. Suppose you were asked to evaluate this iterated integral. Integral from 0 to 1 of times the integral from 0 to 2 of x plus y dx dy. First thing you have to realize is that this is two integrations. It's the integration of what I just boxed. And whatever that is, we integrate that with respect to dy. So first we want to figure out what that first integral is. And once I have that answer, I promise you I will integrate that with respect to y. Okay, so inside the red box, or brackets, the variable here is x. I integrate with respect to x. The integral of x squared over 2 plus, that's a constant. The integral of a constant is the constant times x. And x goes from 0 to 2. That's important to realize that it's x's that go to x equals 0, x equals 2. Otherwise, you might be likely to plug in the value for y. So this is the integral of y of, when you plug in 2, you get 2 squared over 2, which is just 2, plus y times 2, which is 2y. And when you plug in 0, you get 0 dy. Now this is what we want to integrate. This is what we want to integrate with respect to y. So we get 2y plus y squared. The integral of y, the integral of 2y is y squared. And this goes from 0 to 1. Since there's only one variable, y, those are y values, 0 and 1. So when you plug in 1 for y, you get 2 times 1 plus 1 squared. When you plug in 0, you get 0. So the final answer is good old 3. For the next one, you need to recall that the integral of 1 minus y squared to the half, that is the square root of 1 minus y squared, times y dy. Well, if I call this u, if I say, hey everyone, u is 1 minus y squared, well then du will be negative 2y dy. We have the y dy, we just need the negative 2. Not a big deal when it comes to a constant. I can put in the negative 2, but I have to bring out the reciprocal. After all, negative a half times negative 2 is just 1. So then, this is u to the half, and the rest is du. Du. Well, the integral of u to the half du is u to the 3 halves divided by 3 over 2. So I get the negative a half in front times this, times 2/3 times u to the 3 halves. For u has always been 1 minus y squared, and the 2's cancel, so you get negative a third times 1 minus y squared to the 3 halves. So we're going to need that for this integral. I want to get rid of the stuff that I added in. Now, suppose you have the integral from 0 to 1 of, you take the integral of something. I think in the last problem I said times. That's not correct. It's the integral from 0 to 1 of the integral from 0 to the square root of 1 minus y squared of x plus y dx dy. So first we do this. We put all our energy into figuring out what that integral is. Integral from 0 to 1. Well, the integral of x dx is x squared over 2 plus, just say plus, the integral of y dx is just yx. And x is going from 0 to the square root of 1 minus y squared. And whatever that is, we integrate that from 0 to 1 dy. So it's the integral from 0 to 1. When you plug that in for x, you get 1 minus y squared over 2 plus y times the square root of 1 minus y squared. And this is all times dy. So 1 over 2, the integral of 1 over 2 is just y over 2. Minus the integral of y squared over 2. Well, the integral of y squared is y cubed over 3. The 3 is in the bottom times the 2 that's in the bottom. Makes it 6. Plus this integral. But that's what we did on the bottom. And there happens to be our answer. It's negative 1 minus y squared to the 3 halves over 3. And this gets evaluated from y equals 0 to 1. When you plug in 1, you get a half minus, over here you get a 6. And when you plug 1 in for y right there, you get 1 minus 1 squared, which is 0. So this 3 halves is 0. Divided by 3 is 0. Minus 0. Minus. Well, when you plug in 1, I mean 0 here and here, you get 0. Minus that minus right there. When you plug 1 in now, you get, when you plug in 0, you get 1 minus 0 squared in the brackets, which is 1. Because the 3 halves is 1. Divided by 3 is 1/3. So moving upward, you have 1 half minus a 6. Forget about the 0. Minus a negative a third. That means plus a third. Let's write everything over 6. 1 half, 1 out of 2 is 3 out of 6. 1 out of 6 is 1 out of 6. Plus 1 out of 3 is 2 out of 6. 3 minus 1 is 2. Plus 2 is 4 over 6, which reduces to 2/3. So that messy problem, just the number 2/3. So if you ever want to write 5 plus 2/3, you have every right to write 5 plus that integral from, that was the beginning integral. Because that beginning integral equals 2/3. Just a new way of writing 2/3. Sometimes the integral may be improper. How improper? Suppose you had the integral from 1 to infinity. Immediately that's improper. Of the integral from 0 to 1 over x, y dy dx. So first, we just do that integral. Remember, since that's dy's, these values, these limits are y values. So it's the integral from 1 to infinity of the integral of y dy is y squared over 2, from 0 to 1 over x dx. Possibly, I could factor out the 2. That is the half. It's 1/2 the integral from 1 to infinity of y squared from 0 to 1 over x dx. So let's figure out what that is. You plug in 1 over x, you get 1 over x squared. You plug in 0, you get 0. So it's just that. So this is 1/2. I'd rather, from 1 to infinity, I'd rather think of it as x to the negative 2 dx. That way, when I add 1 to that power, because I'm integrating, I get x to the negative 1, and I divide by negative 1. This is from 0 to infinity. This is negative, and this is positive. So the answer is negative. It's 1 over 2x from 0 to infinity. Now, I hate plugging in upper and lower limits with a negative in front. It's way too complicated for me. So this is 1 over 2x. Notice I changed the sign. But if you change the sign of this, you must reverse the order of integration. Okay? I went 99% of the way before I even introduced limits. That is, before I'm even saying, oh, this is improper. I can't let x be 0. So you have to play this game. Take the limit as k goes to infinity of basically that. Really of this. And instead of going from infinity to 0, you go from k to 0. And now we just plug in the upper and lower limit. First you plug in, excuse me, it was from 1 to infinity. It's always been from 1 to infinity. Sorry about that. So again, when you interchange the limits, you get infinity to 1, not to 0. Come on. So when you plug 1 in, you get 1/2 minus. When you plug k in, you get 1 over 2k. Now you take the limit. As k changes, 1 over 2 couldn't care less. But as k goes to infinity, that goes to 0. The bottom goes to infinity. If you take 1, you keep dividing it by more and more. You have 1 pizza pie, and you keep dividing it by more and more people. More people keep saying they want a piece. I want a piece. Please give me a piece. More and more people want a piece of your pie. Well, each person's going to get close to 0. And in the limit, it's 0. So the answer is just 1/2. So there's an example of how you would handle an improper integral. That's when you integrate where one of the limits is positive or even negative infinity. Now, in the next problem, we want to sketch the region, which is called R, the region R of integration. And then we want to switch the order of integration. We'll talk about what that means in a moment. Doesn't matter what the function is. What we want to know is, what does the base look like? What's in the xy plane? Okay, you might have a square in the xy plane, and then the surface comes out. But if you were looking from far above, basically you're looking into the board from far above. Excuse me, you're looking towards the board at this three-dimensional object. What you would basically see is a square, because it comes out. I don't really know how to draw that, but it comes out from the board. But nonetheless, it lies in the plane. In other words, if you took every point on the surface and you just pushed it straight down to the XY axis, to the floor, what you would end up with is this square. That's what we want to know. And then after we know that, we want to switch the order of integration. We want to integrate with respect to y first and then x. Well, what we know is that y goes from 0 to x. Excuse me, we know that x goes from 0 to y. We know that x goes from 0 to y. Well, here's x equals 0, and here is, say, x equals y. But x is always bigger than 0. That really puts us in quadrant 1. X is bigger than 0. Now, x is less than y. That means y is bigger than x. This is y equal x. This point right here, for that x value, I know that y is also x. But for this point above, that y value is bigger than x. That y value is bigger than x. And that's what we want. We want y to be bigger than x. That tells me that it's this area above. Now, I really shouldn't have, I should also say that y goes between 0 and 4. That is, it stops at 4. That is the region that we are integrating over. Now, let's draw it again. Let's look at it a little bit more closely. This is y equal x, the x-axis. This is the y-axis. Now, what does x go from? dx. Looking at the picture, it goes from, well, this point here is 0, and this point here is x, but we want to write x in terms of y. It goes from 0 to y. That's exactly what it says. And then the y values, the least it can be is 0, the most it can be is 4. That's why it goes from 0 to 4. Exactly what it says. But now we want to interchange the limits. We want to put dy first. Well, let's see what y goes from. It goes from this point to this point. It goes from this y to that y. Well, at this point, y is x. And at this point, y is 4. No matter which rectangle you draw, this y value is x, and this y value is the constant 4. And x goes from, well, in this region here, the least x can be is 0, and the most it can be is out there. And I know the y value is 4, and I know that x equals y. So the x value here is also 4. So x goes from 0 to 4. And that's how you would change or switch the order of integration. No matter which of those two integrals you try to solve, you get the same answer. Otherwise, they wouldn't be equal. Now, Suppose we had the integral from negative pi over 2 to positive pi over 2 of the integral from 0 to cosine x of some function of xy. It doesn't matter what that is. Even if I told you what it is, changing the limits will not matter. So I want to change the limits. Doesn't matter what this function is. It's going to be the same over here. It's going to be the same. But we're interchanging the dx and the dy. Okay. So dy, or y, goes between 0 and cosine x. Y goes between 0 and cosine x. And x goes between these numbers. And this is the symbol for x is in between. X is in between negative pi over 2 and positive pi over 2. Here is negative pi over 2. Here is pi over 2. Smack in the middle is the y-axis. And I know that y goes between 0 and cosine x. Cosine x between negative pi over 2 and pi over 2 looks like that. I mean, after all, the sine curve looks like this. And here is negative pi over 2, and here is pi over 2. It's just that piece. Okay. Now, to make sure that I didn't make any mistakes, first I see dy. Well, remember, this is y equals cosine x. No matter which rectangle I draw vertically in the y direction, it goes from 0 to y, which is cosine x. 0 to cosine x. And the x's in this area here, the smallest point that x, the point that has the least x value, namely right here, is negative pi over 2. And the point that has the largest x value is right here, and its value is pi over 2. So my picture there is correct. But since I drew on it so much, let me draw on it again. Remember, the highest value of cosine is 1. So negative pi over 2 to pi over 2. Now, I want to change the limits. I want to talk about x first. I want to talk about x first. So I go from here to here. And the question is, so this is some x value, and this is another x value. But I want to write x in terms of y. Well, I know that y is cosine x. So x is the cosine inverse of y. So it goes from this x, which is negative, the cosine inverse of y, to this x value here, which is positive, cosine inverse of y. And what does y go between? Well, again, in this area here, we have many points that have the least y value. And that least y value is 1. Excuse me, 0. And coincidentally, there's only one y value that has the highest number in this region. And its value is 1. And there it is. There it is. And you can integrate those, but we did a number of iterated integrals, or double integrals. Sometimes it's easier to integrate if the limits were different. Sometimes it's easier to integrate if the limits were interchanged. And we'll see one like that at some point. Suppose you have the integral from 0 to 1. This is an easy one. of the integral from 0 to 2 dy dx. Well, this tells me that y goes between 0 and 2. Okay, y goes between 0 and 2. It's not a function of x. It's just goes between this number and that number. And x goes between 0 and 1. Or x goes from 0 up to 1. So interchanging the limits of integration, switching the order of the integral, well, x goes between 0 and 1. Y goes between 0 and 2. And there it is. And it doesn't matter what the z value is. It doesn't matter. Z, remember z just means f of x, y. It doesn't matter what the height is. Okay, this video is just to show you how to get the right answers. I can't show all the theory behind the, I can't show all the whys. Now, suppose you have this integral. The integral from 0 to 2 of the integral from x over 2 to 1 dy dx. And the problem is to switch the order of integration. That is dx dy. Well, I know that y goes from, y is in between, x over 2 to 1. Now, if y is equal to x over 2, that means, say, 2x is y, or y equals x over 2. Y equals a half x. That looks like this. And it goes up to 1. Now, what you need to be careful is this the area where I put the x, or is it the upper half of this triangular region? Y, x over 2. The arrow is pointing to the x over 2. It should always do that. Y is bigger than x over 2. That's this area up here. Okay, that's the area that we are integrating over. And we want to change the order of integration. Well, let me draw this again, please. This is y equals x over 2. This is 1. So this x value right here should be 2. Because 2 over 2 gives you 1. And the y value right here is 1. X is 2. Y is 1. Okay. Now, what does x go between? Well, I know where this left point is, it's 0. And this right point is y equals x over 2. But I wanted to say what x equals. So multiply both sides by 2, and you get that x is 2y. Okay. We go from 0 to 2y. And the y values, the least y can be is down here, and that's at 0. And the most y can be is anywhere up here, and that value is 1. And there, I switched the order of integration. I switched the order of integration. When they say switch the order of integration, they mean to switch dx dy. That doesn't mean to write dx and dy and say, boy, that was the easiest problem I've ever done. That's not math. yes, you have to switch it, but you also have to make sure it's equal to what you just wrote down, which probably means you'll have to change the limits. Once in a while, you won't have to change the limits. If x goes from 0 to 5 and y goes from 0 to 5, you have the integral from 0 to 5 or the integral from 0 to 5 or some function dx, dy, you could switch these and it'll be the same. But that's not usually the case. Now here's a nice problem. Suppose you have the integral from 0 to 1 of the integral of y squared to the cube root of 1, dx, dy. And we would just love to change the order of integration. I'm going to switch the order of integration. Well, I know that I know that x goes from y squared to the cube root of y. So if x is equal to y squared, that means that y is the square root of x. And the square root of x goes this way. This is y equals the square root of x. X equals y squared will be the portion I just drew plus that portion down there. But, okay. In fact, fine. There it is. There it is. Now, we also know that x is equal to the cube root of y. If I cube both sides, I know that x cubed is y. And x cubed happens to go like that. Now, we're integrating over something. We're integrating over this closed area. We're integrating over that closed area. Y is x cubed, or x is the cube root of y. X is y squared. Right? Now, as I said, we're switching the limits. Now, for the record, this point is 1, 1. I mean, you can set the y's equal to one another, or you can set the x's equal to one another. You can set 1y squared equal to the cube root of y. If you cube both sides, you get y to the 6 is y. Well, you should know this answer. 0 to the 6 is 0. That worked. And 1 to the 6 is 1. That is, if y is 0, these two are equal. If y is 1, these two are equal. And if you really wanted to solve it rigorously, you factor. Now you can factor out a y. And this is 0 when y is 0. And this is 0 when y is 1. If y to the 5th is 1, then y is 1. So it does cross at 0 and 1. That's good to know. Okay, so now, what does y go from? What does y go from? It goes from this y, which is x cubed, to this y, which is the square root of x. How nice. That wasn't bad at all. The least value of y for x, the least value of x happens right here, that's 0, and the most, or the largest x can be, is 1. And there's your switch of integration. I switched the order of integration. Okay, go back and retry it on your own. Make sure that you can do this. Suppose you want to find this area. You just want to find this area that I'm shading in. And I tell you that that curve, that is this here, it lies on 4 minus x squared. It's 4 minus x squared. So we can set up a double integral. Now, it turns out that this is 2 and this is 4 at the top. Make believe that's even given. I mean, you should see it. 2 squared is 4. 4 minus 4 is 0. So when x is 2, y is 0. Okay, and that is 2, 0. And when x is 0, 4 minus 0 squared is 4. So we want to set up some kind of limit. Suppose we want to do dx, dy. Well, x, it goes from 0 to here, to x. Goes from 1x, and actually, what I'm doing is fine, but it's probably easy. Okay, why don't we do this? X goes from 0 to x. Well, if y is equal to 4 minus x squared, interchanging these two, we get x squared is 4 minus y. So x is the square root of 4 minus y. I did not say plus and minus because here, no matter what rectangle I draw, x is always positive. So x goes from 0 to the square root of 4 minus y. And y goes from, well, the least y can be is down here, and that's 0. The most it can be is at this point up here, which is 4. And there's one answer. Let us do it the other way. Suppose I wanted to integrate where I had dy dx. Remember, the y value is always 4 minus x squared. So what does y go from? Well, down here it's 0, and up here it's y, which we call 4 minus x squared. And x, well, in this area, the least x can be is 0, and the most it can be is right there, which is 2. And those two integrals are actually equal to one another. But in this case, it was easier to do the second one. Sometimes one is easier than the other. But nonetheless, you need to know how to do both. Now, suppose you were asked to find this area. You have, once again, y is equal to 4 minus x squared. And you have the line y equals x plus 2. Y is equal to x plus 2. And you're told that it crosses on the x-axis at -2. They tell you that. And it crosses also at the point 1, 3. 1, 3. When x is 1, this will be 3. When x is 1, and this is called y. And when this is 1, that's 3. That is, y is 3. So basically, we want to find this area right here. So since I drew on it, let me draw it again. We want to find that enclosed area where this point is 1, 3. Okay. So it's a double integral. Looks like going vertically would be good. Y goes from here to here. So first we're going to do dy. And the lower value is y equals x plus 2. X plus 2. And the upper value is y. In this case, it's 4 minus x squared. When you look for a y, you shouldn't write down y here. You should write down either a number or y in terms of y of x or y of z or y of t. That is, you shouldn't write down y's. You should write down x's. But it better equal y. What I wrote on top, 4 minus x squared, that does equal y. And then dx. Well, the least x here is negative 2, and the biggest x can be is 1. So negative 2 to 1. And that will give you, that integral will give you that area. So f of yz is 1. That is, now I forget what I put to the limits, but it's just 1 dy dx. The function is just 1, or don't put any function. So the integral will be 1. And then plug in the limits and subtract, and then integrate again with respect to x, and then plug in the new limits. And on that note, that finishes the section, iterated integrals and area in the plane.